This talk in the Building Minds with Patterns series is about the reminding pattern. We will briefly highlight the features of a generic cognitive architecture and discuss design patterns for cognitive systems. Then we will delve into the specifics of the reminding pattern, and finally we will show how this pattern fits into some existing cognitive systems. What is a cognitive architecture? A cognitive architecture is a design for an artificial mind. It's realized in a diagram depicting the elements of the mind that the architects claim are necessary and sufficient to support thinking, or otherwise called cognition. But how do we build such a system in the first place? The answer is simple. We need to establish a list of requirements identifying what the artificial mind will do, and once these requirements are elicited, we can then design a cognitive architecture to fulfill the requirements. So at a very high level, some initial requirements could be that 1. We want an artificial mind to communicate with a device, such as a car, a robot, a smartphone, or an avatar, that is situated in the real world or in a virtual world. 2. The device will send data. We can call this data observables from the world to the mind and receive commands from the mind. We can call these commands actuations. 3. Some components will think about the observables and infer new information about them. We will call these coordination components. 4. We'll need to have the system learn and improve its behavior over time. The system will therefore need to observe its own performance. We will call the components that reflect upon the system's behavior reflection components. 5. We want the system to stay within its capacity for memory and performance and not get slower over time. So we need to periodically consolidate the information stored in the system, and therefore we need components for that as well. These 5 basic requirements can be supported in many different architectures. We now present a generic cognitive architecture template. In essence, a cognitive architecture is a blueprint for an artificial mind. Here we see areas for observation, coordination, reflection, and consolidation, as well as a device situated in the world. In this template, we can see a device situated in a real or virtual world. This device communicates with a cognitive system through observation components, which store input from the device into the system's memory. The observation components are also responsible for communicating with the device's actuators, which perform actions in the world. We also see that there are coordination components which update the memory with new inferences. The reflection components are responsible for changing the overall behavior of the system. And finally, the consolidation components are responsible for ensuring that the memory does not exceed its available capacity. What are cognitive system design patterns? Isaiah Berlin once said, "To understand is to perceive patterns." In building an artificial mind, it's helpful to start somewhere, and preferably not from scratch. There are a number of cognitive system design patterns which can be used to implement the required mind. Mapping requirements to design patterns can assist in defining the overall mind architecture. Some defined patterns are depicted below. This talk's focus will be the reminding pattern. What is the reminding pattern? The reminding pattern stores plans, situations, or episodes in memory as cases for later retrieval. The reminding pattern is most useful when it's necessary for the cognitive system to consult a historical record or retrieve specific cases, situations, plans, or episodes from memory. The perceiver receives observables from a device and forwards the observables to the storer. The storer augments the observables with encodings or indexes, thereby transforming the observables into cases, or situations, episodes, and auto-associatively or heteroassociatively stores the cases in memory. Auto-associatively means that the observables or encodings alone are used to refer to the case. Heteroassociatively means that more than the observables or encodings alone are required to refer to the case. The memory will hold cases and possibly also inferences derived from the cases. The memory itself could be a neural network, database, knowledge base, flat file, or some other hybrid associative memory. The retriever fetches cases from memory using either a logical, similarity-based, or hybrid retrieval method. Forces for using the reminding pattern involve the necessity for the cognitive system to find specific cases, plans, situations, or episodes that match a particular context or situation. What is a cognitive system? A cognitive system is a software and hardware implementation of a cognitive architecture. It is the instantiation of an artificial mind. There are a number of cognitive systems that have been researched extensively. Here is a chart of some cognitive systems and the design patterns they implement. Cognitive systems which have the reminding design pattern are highlighted in yellow with a red outline on the cognitive systems chart. In order for us to study cognitive systems, we have to align them so that their elements are comparable. The characteristics among cognitive systems that seem important are the ability to perceive information from a device, the ability to be reminded of prior events and situations, the ability to create, retrieve, select, and execute actions. These general regions are depicted in the comparison template, and the cognitive systems we study will be laid out accordingly. The JCB system is a conversational knowledge base and control system used for communication, understanding, knowledge retrieval, and task scheduling. Written by Sheldon Linker, it allows users or clients to tell facts, ask questions, and schedule tasks in a syntax very close to natural language. JCB, named after Logland's inventor James Cook Brown, has as a basis the JCB English language, which is an extremely similar language to English, but is an unambiguous formal language capable of expressing commands, and which includes modal logic. The original executive program, also named JCB English, can answer questions based on proofs rather than statistical likelihoods of meanings, accept new information, perform proofs, and decide which statements are worth adding to the knowledge base. The system also provides for multiple users at various levels of trust, so that what is true for one user might not be true for another. A second version, JCB Robotics, adds imperatives in communication with actuators. We see here that the reminding pattern is implemented by a perceiving element which parses the input from a device and determines what to do with it. If the input is identified as an action, the action store places it in the agenda memory. The executor monitors the agenda memory and retrieves relevant actions for execution. Here, the executor serves as the retriever. The Daydreamer program, written by Eric Mueller, represents the initiation of emotions in response to real or imagined events. It also demonstrates emotion regulation as well as the influence of emotions on daydreaming and behavior. This is a partial implementation of the reminding pattern since the perceiving element, in this case the parser, indirectly forwards episodes to an episode store rather than directly. The parser creates contexts which eventually influence the storage of episodes in the episodic memory. An additional reminding element compares new input with episodic memory to determine relevant episodes to retrieve. The Case-Based Planner, or CHEF program, by Christian Hammond, is a seminal work in the area of case-based reasoning. Using experience instead of rules, the CHEF system creates and modifies plans in the domain of Szechuan cooking, using case-based reasoning. The initial plans were hand-coded from recipes. The system augments itself with revised plans based on the results of executing the plans. When plan steps interact and produce unintended outcomes, the plans are repaired, and the repaired plan is stored in plan memory. The significance of this system is the fact that it can augment itself through plan repair. Metadarmok by Antonon and Associates is a case-based planning system that plays Wargus, a real-time strategy game. The system accepts advice from a human critic. The system uses failure patterns to detect anomalous behaviors and learns from experience which failures are salient enough to address. This system is a partial implementation of the reminding pattern, since the perceiver does not directly store the initial cases in the case space. Rather, the cases are bootstrapped by a human advisor who suggests the initial plans to use. The AlphaStar system plays StarCraft II, a real-time multiplayer strategy game. The perceiver controls a camera which partially observes the game. The system is initially bootstrapped by hand with thousands of prior games, which provide the initial policies or strategies for actions to be taken based on observables. Policies are updated during gameplay by several learning components. The storer transforms observables into parameters for the policy neural network. The agents that are managed are also individual neural networks in themselves. So, to recap, the reminding pattern stores plans, situations, or episodes in memory as cases for later retrieval. The perceiver receives observables from a device and forwards the observables to the storer, which transforms the observables into cases and stores them in memory. The retriever fetches cases from memory using a logical or similarity-based retrieval method. Forces for using the reminding pattern involve the necessity for the cognitive system to find specific cases, plans, situations, or episodes matching a particular context. You can read more about the design patterns in the book Building Minds with Patterns, available on Amazon. If you found this information useful, please like the video and subscribe to the channel, and visit us on Patreon. Become a member so that we can bring you more helpful content. Find us on the web at Linktree. We'll see you in the next video.